let's move on to the next topic. So the next topic is how to graph a quadratic equation. There is not really an exact method for it. You'll just have to find two important things of a graph, and then you'll have to sketch. I've given two examples here. For instance, you could probably find the axis of symmetry by using x equals minus b by 2a, and you'd find the axis of symmetry, and then you could substitute the value of the y-intercept, and then you could state the value of the y-intercept, which is c, and you could find the x-intercepts by solving this equation by either of the three methods I've outlined in the previous slides. So here you'd have the axis of symmetry, you'd have the y-intercept, and you'd have the x-intercepts, and hence it would be easy to graph it. I'll probably show you a quick example. So imagine if the x-intercepts were 1 and 2, and the y-intercept was maybe 4. So what you'd do is this would be 1, this would be 2, and this would be somewhere 4. And we know that the axis of symmetry here would be 1.5 because it's right in between the sum of the x-intercepts divided by 2. So yeah, you'd have to connect these lines. You'd also have to find the vertex, and you'd probably get something like this, and you'll just have to connect them. Something like that. And this should be symmetrical to this. So that's our final answer. And then you'll either have to find the vertex, then either find x-intercepts or y-intercept and connect the points. This is how it is. Just you'll have to find that. So the next topic is positive definitive and negative definitive quadratics. Positive definitive quadratics are quadratics which are positive for all real values of x, ranging from minus infinity to infinity. So it belongs to all real values, and therefore ax squared plus bx plus c would be greater than 0. A test you can do to find if a quadratic is a positive definitive is if a is greater than 0, meaning it's an upward opening parabola, and such that the discriminant is less than 0. So we know that if a discriminant is less than 0, meaning it does not have real roots, so therefore it never crosses the x-intercept or the x-axis, so it won't have any x-intercepts and it will never cross the x-axis. So therefore this statement makes sense. Positive for all values of x. So this is a test you could do. And similarly, negative definitive quadratics are quadratics which are negative for all values of x. So therefore ax squared plus bx plus c would be less than 0. Similar to the positive definitive quadratics, you could do a test to see if it's a negative definitive. All you need to do is check if a is less than 0. If a is less than 0, we know that it's a downward opening parabola. And the discriminant must be less than 0, meaning it should not have any real roots. And yeah, this is the condition for a negative definitive. And this is the graph of positive definitive, meaning it never crosses the x-axis, and it's positive for all values of x. And then we have this, it's negative definitive. Okay, so the next topic is where functions meet. So the graphs of a quadratic and a linear function either meet at 0 points, 1 point, or 2 points. So all we need to do is equate the equations together, and we'll have to find the discriminant. And then if the delta is greater than 0, we can conclude that they intersect at 2 points, at exactly 2 points. But if the delta is equal to 0, they intersect at 1 point, and if the delta is less than 0, they don't intersect at all. So now let's try an example. Okay, so this is our question. Let's equate the quadratic and linear equation. Minus 3 equals 6x minus 4. We can transpose the terms to this side. This implies that 5x squared minus 2x plus 1 equals 0. Over here, a equals 5, b equals minus 2, and c equals 1. Therefore, the discriminant or the delta is b squared minus 4ac. This equals minus 2 whole squared minus 4 into a is 5, c is 1, implies 4 minus this would be 20. This equals minus 16. Since minus 16 is less than 0, the linear equation and the quadratic equation don't intersect. Okay, so now let's move on to the next topic. It's problem solving with quadratics. It's a pretty simple topic. So what we'll need to do is translate the information into algebra using variables. And step 2, write down what the x variables mean, like x and y variables, I mean. And write down the units if there are any. Step 3, solve the equation by using a suitable method, any of the 3 outlined in the video. And now let's just solve this simple question. So now let's solve this simple problem. It states that the sum of a number and its reciprocal is 26 by 5. Find the number. So I've written it down. A reciprocal means 1 divided by that number. So first we can multiply all the terms by 5. So that would be 5x plus 5 divided by x equals 26. Now let's multiply by x. So 5x squared plus 5 equals 26x implies 5x squared minus 26x plus 5 equals 0. Now I think that the simplest method to solve this would be using third method, splitting the middle term, because we know 5 into 5 is 25. So minus 25 into minus 1 would be 25, and the sum would be minus 26. So it would be 5x squared minus x minus 25x plus 5 equals 0, plus x into 5x minus 1 minus 5 into x minus 1 implies 5x minus 1 into x minus 5 equals 0. Therefore, 5x minus 1 equals 0 implies x equals 1 by 5 and or x equals 5. Okay, so now we'll just see if this is right. So 1 divided by 5 plus 1 divided by 1 divided by 5 would be 5. So that this would be plus 25 by 5, 26 by 5. So that's right. And now 5 plus 1 by 5. This is also 26 by 5. Therefore, this is correct. And we are done with quadratics for additional math chapter 3.